All right, I'm going to lead you through how we do these, just for those who need it. So I'm looking at this formula, CH3Br. The first thing I'm going to do is write the valence electrons above and the bonds below. So C is here in the first column, group 14, so that is 4 valence electrons and 4 bonds, because 8 minus 4 is 4. And we put 4 above and 4 below. H is over here, and I see it has 1 bond, and up above it has 1 valence electron, or I can see that on the periodic table as well. It's our exception to the octet rule. It's always 1 and 1. Br, might have to look a little bit more carefully to find it. I'm going to look at the table, and I see, remember we're always in this triangle here, and then hydrogen, so I see Br is here. It's got 7 valence electrons, and that means 8 minus 7 is 1 bond. It's going to look like an F because it's in the same group as F. So it's 7 valence electrons and 1 bond. I'm going to put the one that needs the most bonds in the middle. So I'm going to put a C in the middle. And then I have 3 H's and a Br. I'm going to start putting those around the outside. 3 H's and a Br. Now I'm going to connect with single bonds. Always, we know at least there's single bonds. Sometimes our arrangement doesn't work out, so let's check to make sure everything has the right number of bonds. My C should have 4 bonds, and I see around the C 1, 2, 3, 4. So that's good. My H's should have 1 bond, and I see the H's also have 1, 1, 1. So that's good. And my Br is supposed to have 1 bond, and I see my Br has 1. So if my bonds are all correct, I don't need to add any doubles or triples. Now for those of you who are trying to do the unshared pairs, because that is actually better if we show those, I'll show you how to do that. So when you look at the valence electrons and the bonds, every bond has 1 valence electron in it from the carbon, and every bond has 1 from the other atom. So if the carbon makes a bond, it needs to use 1 electron. So when these numbers match, that means there's no dots. And so we see that carbon never has any dots. We see that on our chart here. It never has any unshared electrons. When I see hydrogen with a 1 above and a 1 below, that means it doesn't have any unshared because its 1 electron is in its 1 bond. But the Br with 7 valence electrons and only 1 bond, that means 1 is being used in the bond and the rest, there's 6 more that are unshared. So I'm going to put 6 dots on the Br. And that's it. But if you do without the dots, as long as your bonds are correct, you will get credit on the test. Let's do this one. Hydrogen. Look again. Again, hydrogen is our exception to the rule. Let's get rid of some of this. It's in group 1 with 1 valence electron, but I'm remembering, and I hope you are too, that it still just has 1 bond because it's the exception to the octet rule. It only needs 1 bond to fill that first energy level. And so here I have 2 hydrogens, and they are going to go like this since they need the same number of bonds. I don't really have one in the middle or one that needs more. Connect with a single bond to start. Now check, do you need to add a double or a triple? And I look and I see each hydrogen just wants 1 bond, and right now they each are touching 1 bond, so that is good. For the dots, when the number above and below are the same, that means there's no unshared electrons because the 1 electron that it has is in the bond. The bond represents 2 shared electrons, 1 from each hydrogen. So no unshared here. Let's try this one. NHO. Let's do valence electrons and bonds. So here I can use my bond chart pretty easily since N is the example they gave. I can also find it over here. N is in group 15, so it has 5 valence electrons, and 8 minus 5 means it has 3 bonds. So I'm going to put above 5 and below 3. Hydrogen, we just did it. Do you remember? I hope you remember 1 and 1. 1 electron and 1 bond. Oh, let's look that one up. Again, it's the example, so you can use this chart pretty easily. It has 6 valence electrons and 8 minus 6, 2 bonds. Now think about the steps. The first thing is to put the one that needs the most in the middle. When somebody in your life needs a lot of help, you all surround them. The family surrounds them. So we're putting the neediest one, the one that needs the most bonds, in the middle. Then we're going to put the other things on the outside. I only have one H and one O. I usually try to put one on each side when it's like that. So I'm pretty sure they're both going to need to bond to the nitrogen. The nitrogen has to be in the middle. Start with a single bond. Now let's check our bonds and see if we need to add any double or triple. So I'm going to count for nitrogen. It's supposed to have 3 bonds, and I see 1, 2. Oops, it needs 1 more. So we have to figure out where that 1 more is going to go. I've noticed a couple people putting it like this to nothing. We can't do that. It has to bond to something. So it has to go in one of these places. We need a double bond. Let's see where. The hydrogen needs 1 bond, and I see this hydrogen. It already has 1 bond. We can't put it there. How about the oxygen? Oxygen needs 2 bonds, and here I see it only has 1 bond. So if both the nitrogen and the oxygen need 1 more, that's where I'm going to put it. Just kind of makes sense. They both need 1 more, so that's where you put the double bond. Now let's do the dots. If I look at the valence electrons for nitrogen and the bonds, they don't match. 5 valence electrons and only 3 bonds. That means if I kind of cancel out 3 of the 5, that means there's 2 left that are unshared. So I'm going to put 2 dots on the nitrogen. For the hydrogen, looking at the here, it has 1 and 1, so they cancel. So no dots on hydrogen. And for oxygen, now looking here, we have 6, and then we have only 2 in the bonds. 2 bonds means 2 electrons are being used by the oxygen there. And so when we subtract 6 minus 2, we know there's 4 dots or unshared electrons left over. So the other way to do it is to look at your bond chart, and you see that in green, nitrogen always has 2 dots here, and oxygen always has 4 dots. Let's get rid of that for our next one. So that's it. Let's try this one. Now this time I'm going to do something wrong, and we're going to see if we can catch it. So I'm going to start with valence electrons and bonds. Nitrogen, we just did it, but let's double check. 5 valence electrons and 3 bonds. Hydrogen, it comes up in almost every one, doesn't it? So I hope you're remembering 1 and 1. Fluorine, let's look here. Fluorine's our example from group 17. We can also look over here. It has 7 valence electrons, and 8 minus 7, it makes 1 bond. Now let's start. All right, I'm going to put N, H, F, and I think N needs a lot of bonds, so I'm going to put a H over here too, so N's in the middle. Now I'm going to start connecting with single bonds. Now let's double check. Does everyone have what they need? Nitrogen needs 3 bonds, and I see this nitrogen has 1, 2 bonds. So it looks like nitrogen's going to need another bond. Let's see where it can go. Hydrogen needs one bond. This hydrogen has one, so it's good. Now this hydrogen has 1, 2. Oops, that's my mistake. You can never give hydrogen 2 bonds because it only wants 1. Atoms only do what makes them stable. So let's back up. If you have that happen, it's probably easiest to just start over. And our mistake was we didn't put the one that needs the most in the middle exactly. So I'm going to start with the N in the middle because it needs 3 bonds and start putting the H's around it instead of having them in a line. Now if I connect with single bonds, so this is what we mean by the arrangement of the atoms. Before I had them arranged in one line, now I have them arranged a little differently. Let's see if this works better. 3 bonds for nitrogen, 1, 2, 3. Oh, now it got its 3 bonds. That's good. 1 for hydrogen, 1 for this one, good. 1 for this one, good. So that's good. Now fluorine. 1 bond for fluorine, and I see it has 1 bond. So everyone has got the bonds they need. If you stop here, you'll get full credit for the test, but I know some of you are trying to do the dots, and it's really good if you do. So when we look at the valence electrons for nitrogen, 5 of them, but only 3 bonds, that means there's 2 left over that are unshared. For hydrogen, 1 electron and 1 bond, that means its 1 electron is in the bond, it's represented by the line already. Fluorine, 7 and 1 means 1 electron's in the bond, but it has 6 more dots. So this is really the best way to show fluorine. Looks like I accidentally have a little dot there. That shouldn't be. All right, this is it. Please come to Google Meet if you need more help.